In this video, we'll be talking about limits of polynomial and rational functions. So by now you have probably noticed that in each of the previous examples that we solved, it has been the case that lim of f of x as x approaches a is equal to f of a. Okay, so this is not always true, but it does hold for all polynomials for any choice of a and for all rational functions at all values of a and for which the rational function is defined. So let's look at the theorem for limits of polynomial and rational functions. Okay, so let's p of x and q of x be the polynomial function. So we have this one to be the polynomial function. Then we are going to let a be the real number. So we are going to let a be the real number. So if a is the real number, then we will be having lim of p of x as x approaches a to be equal to p of a, which can be defined as lim of p of x on q of a as s approaches a will be equal to p of a on q of a, when this condition only holds when q of a do not equal to 0. Okay, so in short, to see that this theorem hold, consider the polynomial. Let's look at this, how this condition hold. Okay, so to consider the polynomial p of x should be equal to c the subscript of n, then x exponent n plus c subscript n minus 1, then x n plus c. So let's just end here. We're not just going to continue with this one. So plus the continuous plus c1 x plus c0. Okay, so by applying the sum, the constant multiples, and the power laws, we are going to end up with the lim of p of x as x approaches a. That will be equal to the lim of x as x approaches a. Okay, then into bracket of cn xn plus cn minus 1, then x exponent of n minus 1, then plus, which continues to be plus c1, then x plus c0. You close the bracket. Okay, so when we simplify this, we should be getting cn out, then open bracket lim of x as x approaches a, then you close the bracket, then exponent n. Okay, then plus cn minus 1, you open bracket the lim of x as x approaches a, then you close bracket, then exponent of n minus 1 plus, which continues, then plus c1, then you open bracket, lim of x as x approaches a, then you close bracket, then plus lim of c0 as x approaches a. Then if you continue to simplify, I'm trying to simplify to the lowest term that we can get, okay? So when we simplify further, we are going to get cn a exponent n plus cn minus 1 a exponent n minus 1 plus continuous, then plus c1 a plus c0. Then finally we come to p of a. Okay, so it now follows from the quotient law that if p of x, okay, and q of x are polynomials for which as we said the q of a shouldn't be equal to 0, then we'll be having lim p of x as x approaches a on q of x should be equal to p of a over q of a, as we stated above. Okay, so let's look at some example that applies to this concept here, or this theorem. So with this example, we are going to evaluate. So let's look at this one. So example 1. Let's evaluate lim 2x squared minus 3x plus 1 on 5x plus 4 as x approaches 3. Okay, so let's look at how to solve this. Now, since 3 is the domain of the rational function, f of x, okay, which is this number here, or this equation here. So since 3 is the domain of the rational function, f of x, which is equal to the 2x squared plus 3x plus 1 on 5x plus 4. Okay, we can calculate the limit by just substituting the 3 for x into the function. Okay, so when we do that, it's become very simple. So we will have 2 open bracket 3 squared plus 3 times 3 plus 1 on 5 open bracket 3 plus 4. Then when we do it, you get 2 times 9 plus 9 plus 1 on 15 plus 4. Then we should do it further, we should get 18 plus 9, or 10. Let's just add 10. Then 19. Then we'll have 28 over 19. Okay, so there was kind of mistake here. So here it was minus. Okay, let's correct that. So here it was minus, so we should be having minus here. So minus minus. So let's just, instead of the 28 over 19, it should be 10. It should be 10 rather. So 10 over 19. Okay, it should be 10 over 19. Now you can try this on your own. Try this on your own. You can pause the video and try this on your own. Evaluate lim of 3s cubed minus 2x plus 7 as x approaches -2. You can pause the video and try this on your own and put the answer under the comment section. Okay, now let's look at another thing here. We are going to look at the additional limit evaluation techniques. Okay, so as we have seen, we may evaluate easily the limit of polynomials and also limit of some but not all rational functions by direct substitution. Okay, however, as we saw the introduction section on limit, it is certainly possible for that we will be having a limb of maybe f of x as x approaches a to exist when maybe f of a is undefined. Okay, so we come when f of a is undefined, what are we supposed to do? Now, the following observation, what I'm gonna write down here, are gonna allow us to evaluate many limits of this type of conditions when we meet this kind of conditions. Okay, so if for all x, okay, is not equal to a, where we have f of x being equal to g of x over some open intervals containing a, then the limb of f of x as x approaches a will be equal to the limb of g of x as x approaches a. Okay, so to understand this idea better, let's consider this better. So when we have maybe the limb of x squared minus 1 on x minus 1, where x approaches 1. Okay, now the function becomes f of x be equal to x squared minus 1 on x minus 1. Okay, so with this we can evaluate this, or we can simplify this to be equal to x minus 1 then x plus 1 on x minus 1. Okay, and the function g of x, so let's say g of x is equal to x plus 1, are identical for all values of x not being equal to 1. Okay, so let's look at the graph here. Let's look at some graph. Okay, so let's say we have two graphs. Okay, so let me draw one graph here and another graph here. Okay, now let's name this graph as the function for g of x, which is equal to x plus 1, and this graph to be f of x to be equal to x squared minus 1 on x minus 1. Okay, now let's plot this graph right here. So let's name 1, 2, 3, then lastly 4. 1, 2, 3, then 4. Okay, this is the y and this is the x. Negative 1, negative 2, negative 3, negative 1, negative 2, negative 3. Okay, now when we look at this, we are gonna plot it from the 1 to 1. Okay, so let me use the blue color here. So 1 passes through. So this is the graph for the function g of x equal to x plus 1. Okay, now let's look at this one too. So we have 1, 2, 3, 4, 1, 2, 3, then 4. We have the x axis. Okay. So let's look at the graph again. I think my graph got lost. So this is my graph for the first one, which is 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So g of x equal to x plus 1. Then when you plot it, it's gonna pass through here. Okay, then when you look at the another graph for the f of x, 1, 2, 3, 1, 2, then 3, then negative 1, negative 2, negative 3, negative 1, negative 2, then negative 3, y-axis, x-axis. Okay, when you plot the f of x, which is equal to the x squared minus 1 on x minus 1, when you plot that, it should also pass through the right here with the interval continuous. Okay, so now when we look at these two graphs, now the graph of f of x and the g of x are identical for all x not being equal to 1. Okay, and their limits at 1 are equal. Okay, so we can see that the limit of s squared minus 1 on x minus 1 as x approaches 1 will be equal to x minus 1 multiplying x plus 1 on x minus 1. Okay, then when we do that, so this cancel this, then we have a limit of x plus 1 as x approaches 1. Then when you put the x, you substitute the x into the function, you should get 2. Okay, so the limit has the form of, the limit will have the form of lim of f of x as x approaches a, then g of x, where we know that the lim of f of x, where we know, like, so where the lim of f of x will be equal to 0 as x approaches a, and the lim of g of x as x approaches a will be equal to 0 as well. So in this case, we say that g of x on f of x on g of x has the indeterminate form of 0 on 0. Okay, so the following problems that we are gonna solve will tell you. Okay, so now let's look at some of the problem solving strategy. Okay, calculating the limit when the f of x on g of x has the indeterminate form of 0 over 0. Okay, so what we need to do is, you get to listen. First of all, we need to make sure that our function has the appropriate form and cannot be evaluated immediately using the limit laws that we use. Okay, now the second thing that we need to do is we need to find a function that is equal to h of x. Okay, to find a function, the second thing is that we need to find a function which is equal to h of x being equal to f of x on g of x. Okay, for all x not being equal to a over some interval containing a. Now to do this, we may need to try one or more of the following steps. Okay, so to do the second step, we may need the following step that I'm gonna mention to do so. Okay, so first of all, if f of x and g of x are polynomial, we need to factor each function and cancel out any common factors. Okay, let me say it again. If f of x and g of x are polynomials, we should factor each function and cancel out any common factors. Now the second thing that we need to do for the second step is, if the numerator or the denominator contains difference involving a square root, we should try multiplying the numerator and denominator by the conjugate of the expression involving the square root. Again, if the numerator or the denominator contains a difference involving a square root, we should try multiplying the numerator and the denominator by conjugate of the expression involving the square root. And lastly, if f of x on g of x is a complex fraction, we begin by simplifying it. And lastly, the step for 1, 2, then 3 is that we apply the limit laws at last. Okay, so I know it's a little bit complicated, but we are going to look at some examples. Okay, how to use that. Okay, so let's look at the first example. Now the first example is let's look at the lim of x squared minus 3x, where x approaches 3, on 2x squared minus 5x minus 3. Okay, so we have this problem. Now let's apply the first step. Okay, so the function, so we have the function, so the first step, so step 1, so all this is for step 1. Okay, so we have the function f of x equal to x squared minus 3x on 2x squared minus 5x minus 3. Okay, now this function is undefined for x equal to 3. Okay, so this function becomes undefined when x is equal to 3. So in fact, we can substitute 3 into the function and we are going to get 0. If you doubt me, let's just try it right here before we continue. If you doubt me, let's try and see. Now when you put 3 inside, you should get 3 squared minus 3 times 3. Okay, here is 9 minus 9, which is 0. So the up one, the numerator is given as 0 already. Now the down one, if you look at it, 2 multiplying 3 squared minus 5, 3 minus 3. Okay, so this is 9 times 2, 18. This is 15 minus 3, which is 18, 18, so which is 0. So 0, 0. Okay, so this is undefined. Now, so the first step that we're going to do is to factor and cancel, which is the good strategy to do. Okay, so let's do that. Now, if you have to factor and cancel, this is what we are going to do. So we have to write the length of x squared minus 3x as x approaches 3 on 2x squared minus 5x minus 3, which will be equal to the length. Then we have to bring x out. Okay, so x out into bracket x minus 3 on, okay, as x approaches 3. Okay, now here too we have to bring 3 out. We have to this one is equation, this equation. Okay, so this equation, when we do it, we should get x minus 3 into bracket 2x plus 1. Okay, so if you don't know how to do this type of equation, watch my video on that, how to simplify this type of equation. Okay, so when we simplify this equation, we are going to get x into bracket x minus 3 on x minus 3 multiplying 2x plus 1. Okay, now if we should simplify it, we can see that we are going to get this cancel this. Okay, then we'll get the length of x as x approaches 3 on 2x plus 1. Okay, so this is what we are gonna get. Okay, so the step 2, which is the cancel, we just did the cancel. Okay, so the step 2 is for all x not being equal to 3. Okay, x squared minus 3x on 2x squared minus 5x minus 3 will be equal to x on 2x plus 1. Okay, so therefore the length of x open bracket x plus 3 on 2x squared so let me just clean this one right here. So the length of x squared minus 3x over 2x squared minus 5x minus 3 will be equal to, so this x approaches 3 will be equal to x on 2x plus 1. Okay, which is length. Let's bring the length here as x approaches 3. Okay, Now you've gotten it. Now lastly, the last step here is to evaluate using the limit loss. So step 3, we have to evaluate using the limit loss. So when we do that, we should get then when we put the 3 inside, we should get 3 on 2 multiplying 3 plus 1, which will be 3 on 6 plus 1, 7. Okay, so this will be the our answer. Very simple to do. Very simple to do. Very simple to do. Now you can pause the video and try this on your own. I have another one right here that you can try on your own. So evaluate lim of root x plus 2 then minus 1 on, no, that shouldn't be the question because we haven't tried this one yet. So this one will be evaluate lim as x approaches -3 then x squared plus 4x plus 3 then x squared minus 9. So you can try this on your own and put your answer under the comment section. If you have any question too, you can also put it under the comment section. So I'll end this video here and try to continue in the next part, which is part 3 of Libit, where we solve more questions about the square root when it involves square root. Okay, so watch my next video, and if today's your first time here, subscribe, like and share. Thank you for watching. Bye bye.